Hello, and welcome back. I hope that you are having a good day today. I'm feeling a lot better than I did yesterday. I'm mostly recovered from this illness. I still have a lingering cough, but other than that, feeling a lot better today. So I'm doing well. I wanted to jump straight in and continue our conversation that we started last time. And if you remember from last time, we were essentially talking about the problem. Why is it dangerous to have artificial intelligence systems that are as powerful as humans, as capable as humans? Why is that dangerous to humanity? And we talked at first just about the problem of scale, the problem of the latent capacity of these systems, because a model is running on a computer, and a computer, just because of how it's designed, has certain advantages over a biological organism. And it's just a fact that you can make a model that is running on the computational output of a massive data center, a huge warehouse that is packed with the most high-end GPUs you can find, powered by the enough energy to power an entire city, and cooled with a huge amount of water. And that amount of computational power that this one data center can match, definitely totally outstrips what the computational ability of a single human being, or even of all human beings put together. So if you have a model that can match humans in their reasoning ability and their planning ability, and you run it on something like that, then it will just completely overshadow us, completely outmatch us. And it's easy to intuit that would be very difficult to control. So today I wanted to talk about another aspect of this problem, which is agency, which is that there's a degree of agenticness in these models as well. So let's very briefly talk about how these models are actually trained. So training comes in two phases. There's pre-training and then there's post-training. And you can think that pre-training, the goal of pre-training is to create your base model, your next token, or we can think of next word predictor. So the goal of pre-training, at the end of pre-training, is you want a very, very, very good autocomplete. You want to produce a model that is very good when you give it a certain amount of input text to predict what the next piece of text will look like. So now that sounds like, autocomplete, that's not that dangerous, that's not that impressive. But I remember hearing a very good example from someone who was trying to explain why this is like a really big deal. Why actually optimizing a model to accomplish that, to predict the next piece of text, is actually a very significant accomplishment. And they were saying, imagine that you have a detective work. You have this book that is all filled with like clues about and you have suspects, and you have the detective is going through like a Sherlock Holmes story. And the detective is going through and interviewing different people, noticing different signs. And then in the very last scene of the book, the detective brings everyone together, and they, recap everything that they covered in the book. And in the final sentence, they say, and so after considering all these things, I know that the killer is, and then predict that next piece of text. And if you train a model enough, and the model is able to predict that piece of text as well, then in some sense, a model has a representation of the world that is good enough that it is almost as good as the detective, that it can piece together, that it is as good as the detective, it can piece together all the context clues that from the text of the book, to be able to come up with that output. So if you're, or rather, take another situation. Let me tell you, a lot of like MCAT questions, which is boards for doctors and stuff. They have to take boards, and so I was talking to a friend of mine who was telling me about boards, and he was saying that a lot of the questions go something like, an agent is a 26-year-old male and presents with blah 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 blah, and it gives you their whole history, their whole medical history, and then it says, and so they likely have, and then you get a multiple choice, and it's like influenza or whatever other diseases they can potentially have, and now predict that word. In some sense, to be able to do a good job of predicting that next word, you need to kind of understand medicine. So just by super optimizing for predicting the next word, already a model is receiving a lot of deep insights about the world. It's what we can say is it has a good representation of the world. It understands a lot of deep connections. It understands medicine. It understands detective work to some degree. It understands, if you're going over legal documents and you're trying to predict the next word, you need to kind of understand the law in some degree to predict what the next word is going to be in the legal document. And if you're training on the entire corpus of text on the internet, then you're learning about a lot of different kinds of things, even things that you would be surprised by. Like, models have pretty good visual reasoning, even though purely text models, they don't see any images. They don't have any any direct perception of the outside world. Yet from the text data, because humans are often describing physical spaces, they, by being really good at predicting the next word, are actually pretty good at coming up with understanding a representation of the physical world. So that's pre-training. Now, you're essentially making a very good next piece of text predictor. Now, the next stage is post-training. And post-training, you do a few different things, but they are geared to accomplish two tasks. First, you want to give this. So right now, the model that you have, this base model, is only predicting the next word. If you give it some text input, it will just generate what it thinks the most likely next output is. The task of post-training is to take this base model and to give it a persona, to make it act in a certain way. So you're beginning to make what you can think of a sort of agent based on this base model understanding of the world. So how do you accomplish this? There are a variety of different techniques to do this. There is supervised fine-tuning, which is a part of this post-training that happens, where you want the model to produce certain types of outputs. There's also, you can literally just give it examples, like a few shot. This is models are few shot learners. So you give it a few examples of how you want it to act, because you don't want your model to just predict the next word. If you're like OpenAI making ChatGPT or Anthropic making Claude, you want it to act as a certain type of persona. You want it to be a helpful assistant to the user. So you want it to understand that the person that is prompting it is the user, and they have a certain question, and that it should answer as the assistant and not just complete whatever text that they have inputted. So you have a bunch of these steps that are all geared at introducing, trying to impress this persona on the model to act in a certain way. And then there's another goal of post-training as well, where you can actually improve a model's ability to accomplish certain tasks or complete certain problems, especially problems that have obvious solutions. So like, this is usually the technique that would be used to accomplish this is reinforcement learning. So you take a domain like, for example, programming, You can tell if you have successfully, so if you're giving a problem to solve, a programming problem, you can verify that someone has solved the problem correctly or not. So you give the model a ton of different programming problems, and you have it try to solve these problems, and through the same feedback loop of having it try to solve the problem, and then if it succeeds, you reward it for succeeding. If it doesn't succeed, you change it in the direction that would make it succeed more in the future. Through the same learning technique, you can improve its performance in these domains, in programming, for example, in solving mathematical problems, in solving maybe multiple choice questions in different subjects, if those have a clear, correct answer. So you have your base model that you're making very good at predicting the next piece of text that comes, and with that comes all this understanding about the world implicitly. And then you take that and you give it a persona, and you do a few other things, like you make sure that it doesn't you add some extra checks to try to make sure that it doesn't say anything bad, because there's a lot of text in the internet. It might predict the next piece of text if it's just going strictly based off of what's in the internet. Might not be something that you want your model to output. And so there's steps to try to try to make sure that a model is answering in a certain way, that it's nice and it's helpful to the user, and you give it some examples for how it should act. And then after that, you train it more in certain domains, like in programming, in math, other domains. And then at the end of this process, then you have your ChatGPT or your Claude or your Gemini. And now I ask you, out of this process, when you're interacting with ChatGPT, I have this experience, and I wonder if you have it too, where you do feel like there is actually some persona there. It really is less like this random this like model that's just predicting the next best text. I don't know why that's so hard to say, but it's less of that, and it actually becomes more of a certain persona that you're interacting with. It's really good at imitating a persona. This model, after generalizes from all this text prediction, and then you give it a few examples, it's really good at imitating that persona. And you do get kind of a coherent persona that forms from that. So that's ChatGPT, that is Claude, that is Gemini. And now I want to go a step beyond that. Well, actually, before we go to that, I wanted to mention one more thing, which is tools. So, in addition to generating text, if your model can actually produce code, then it's pretty straightforward to also allow it tool access. So, you can have your model, for example, search the internet. You can have it look through files on your own personal computer. You can have it pull up documents and read those documents for added context. You can have it write to certain documents. You can have it compose messages on different platforms, maybe emails, and send them. You can have it put dates on a calendar. You can have it make websites and even deploy them. You can have it buy things from online. So not only can this model, does it have a persona, not only is it really good at solving certain types of problems, like in certain domains like programming, like mathematics, where it's been trained with this reinforcement learning in these on all these problems that they give it. Not only does it have a generalized understanding of the world based on being really good at predicting the next word, but in addition to all of that, you can also give it this tool, all these tools that it can use to interact with the world in different ways. And if it's on the internet, then it can interact with the world in a whole host of different ways, because computers are set up to be able to network with each other, to be able to interact with each other, to retrieve information, to give information, to perform all sorts of actions that require computers to communicate. And then, so you do all of that, and then I wanted to bring one more point that really I have found that drives to people's consciousness, that drives into their minds the danger that this presents in a very, very obvious way. So right now, I think a lot of the reason that people don't see the danger is because ChatGPT, if you're not talking to it, it's just dormant. It's just sitting around. You have to prompt it, and then it responds to you, and it gives you the text output back, right? But then at a certain point, it gives you an output. It can be like 2 paragraphs, 3 paragraphs, and then it stops. And you could reinforce that output 2 different ways. Either you can reinforce that stoppage with like a strict limitation on how much output your model should give. So with ChatGPT, for example, they won't allow you to go beyond a certain point. So like when you give it a prompt, if you tell it, write me a 50-page essay, it won't write you 50 pages. It will still be restricted to like 3 paragraphs or 5 paragraphs or whatever. Also, another way that you can have it terminate is they have a certain like termination token. So when it's producing text and it's producing and it's producing the next most likely token, the next most likely piece of text, you have a piece of text that is just like a signal that it should end its output. And you have that as one of the possible pieces of text that the model can produce, or symbols that the models can produce. And so when you hit that end of text token, then you just stop the output. And so that gives you the model that is interactive, that I've heard some people talk about before as a sage model, where it's like it's dormant until you ask it something, and then it becomes active and it gives you some output, and then it stops at some point and goes back to being dormant. But there's absolutely no reason why this has to be the case. You could very easily take away the limitations on the number of tokens that the model's outputting, take away those restrictions about how long the output has to be. You could very easily suppress that end of sequence token, that like I'm done outputting token, and then the model will just be active continuously. It will just keep outputting more and more and more and more text, more and more text. And now, can you begin to feel the danger here? You have a model that understands the world really well, that can predict the next token on almost everything, in law, in medicine, in literature. And so it has all this implicit understanding about the world. It has a certain persona that it's acting as, that it's operating as, and it presents as a perfectly coherent personality. And it's really good specifically at programming, specifically at mathematics, at all these domain-specific tasks. And it has all this tool ability that it can reach out to the world, reach out outside itself to either things that are on your own computer, or can make API calls to other endpoints on the internet to perform actions in the world. And that is constantly active. Now you're getting something that's pretty dangerous. Now you're getting something where if you can maybe imagine that if a person makes a bad persona and takes exactly the same formulation for designing these models, takes away makes it constantly produce tokens, and then makes the persona an evil persona with bad motives, that's already pretty dangerous. And even the contention is that even if you try to make a good persona, that bad things might happen with this setup. So, all right, I'm thinking whether to keep going or not. It seems like we've already been going for quite a while now. I will just go ahead and stop there, but you can already begin to feel part of the danger. So we've covered now two aspects of this safety problem. We have covered we've covered the latent potential that these models have. We've covered the agenticness that these models tend to have after training, and that you experience when you interact with them, with these base models. Like, just put that aside from people who are explicitly setting out to design agents that operate autonomously. Like, that's a whole other domain too. But what I'm saying is that even with the models that are most controlled, there's already this agenticness that begins to creep in, this autonomy of action. But anyways, so we covered these two aspects. We'll keep on the same thread to talk about approach the same problem from different angles in the next few days as we discuss this more and more. But hopefully, through this experience, you're beginning to have an appreciation for the danger of the thing. But we can talk about that more next time. Thank you so much for listening, and I will talk to you guys again hopefully tomorrow. But till then, take care.